All right, hi everybody. I really appreciate you coming out. I think it's a pretty big crowd, and I'm a little bit humbled by how many people are here, so I will try my best not to disappoint you. As Michael said, I'm Paul Ganssle. I'm a software developer at Google. And I'm also a contributor to a lot of open source projects. So as he said, I'm a core developer of Python. I'm a maintainer of setup tools, and I maintain DateUtil. And as a library maintainer, I spend a lot of time thinking about interfaces. So how programmers are going to be interacting with the code that I write, what the documentation is going to look like, and how they're going to discover the functions that I'm trying to make available to them. So of course, if I were to give all my thoughts on this subject, this talk would be like 3 hours long. But I only have 30 minutes. So what I'm going to do is I'm going to drill down to one specific thing, which is how do you namespace functionality, and how do you deal with functionality that is fundamentally similar to other functions and other ways that you could accomplish the same thing, but different enough that you have to make a distinction between them. Before I get started, I just want to let you know that on my website, which is, oh man. Haha. Hidden behind the curtain. On my website, you'll be able to see the slides here. It's under talks. So there's a couple code-heavy slides. You do not have to understand all the code in order to understand this talk. You just like let it wash over you. And afterwards, if you're like, what did he do there? Just go on the website, look up the slides, or just come talk to me, because I'm a friendly guy. OK, so let's get started. The first thing I'm going to talk about is some general principles that I think are going to come up time and time again throughout the talk. The first one of these is that related functionality should be grouped together. So that means that you could do things like namespacing your functions by module. So for example, the square root function. If that was just a built-in that was always available in the top level function when you open Python, that would be fine. No one would be confused by it. But it's in math that reduces the amount of stuff you have to import at the beginning. It doesn't clutter up the top level namespace. And you're still going to find it, because it's like what module are you going to look for square root in? It's obviously going to be math. It's not going to be in text wrap or anything. There's also functions that are namespaced where the namespace actually really matters. So for example, the get function in the requests module. So requests, if you just had this function called get, and it was at the top level with no namespacing, you'd be like, what does this get? I have no idea. It's just getting something. But when it's namespaced under requests, you're like, oh, this is obviously for making requests. There's a thing called get, which is a type of request. It probably makes a get request. And it's actually a simple and intuitive name. You can also namespace things by class. So for example, the string class has a strip function that operates on the string. The datetime has a class method called from timestamp. Basically, these are namespaced by the class because they're functions that are really only intended to work on that class and its subclasses. So somewhat related to this namespacing thing is that interfaces should be discoverable. So ideally, what would happen is you put out a library, and then your users will read your documentation from beginning to end and fully understand it before they write a single line of code. So I'm going to pause for laughs there, and then we're going to actually look at what people really do, which is that they open up IPython or PyCharm or something, and then they start typing something. They import your module, and then they start tab completing, and they say like, oh, I don't know, what's here? Like, let's look at it. So they also can do things like they'll just open up a REPL, and they'll call dir on your module, and they'll look at all the stuff that's there and try and ignore the things that have too many dunders or whatever. This is one reason to namespace things, right? In that you want them to be discoverable in the way that people are actually going to be discovering these things. Additionally, and increasingly, people are going to be using static typing information to try and figure out what you do with a function, right? So you look at a function and you say, oh, this thing takes a string and an integer, and it gives you back some sort of a token or something. It's like, OK, I kind of know what I want to pass in, what I have to pass into it, which brings us to the next general principle, which is that you should think about your function signatures, because having a complicated function signature should be sort of considered a code smell to you. So I've picked as an example for this, relative delta from the datetime or the dateutil library. I picked something from one of my libraries because I don't want to put anybody else on the spot. And if you look at the the type signature for this, you'll see, all right, it takes DT1 and DT2, and those are date times, and then it says years and months and year and month. And if you look at this, like you say, all right, I don't really know how to use this. Everything is optional. What happens if I pass it nothing? I don't really know. The way it's actually supposed to be used is that it should have one of these two function signatures. Either you pass it 2 datetimes, and then it subtracts the 2 of them and gives you back a relative delta from the difference, or you pass it these different parameters, years and months, and year and month, and there's a whole bunch of other keyword arguments. And I'm not really going to get into the fact that year and years do 2 completely different things and are separated by a single S. But needless to say, it's not the greatest interface, despite the fact that it is an incredibly useful class. So that's one situation where having nice function signatures would make our interface more discoverable. We can also look at this other situation, which is some contrived class which sends a request, and the request is of request type. And the way it would work is that possibly this request has some context that most people don't care about, and what you're doing is but sometimes some people do care about it. So you can pass this return context thing, and if it's true, then it'll return both the response and the context, and if it's false, the default, it'll just return the response. So you can probably tell from just reading it without the types that maybe that's what it does. But if you're looking at the typing, it's like the fact that the function logic itself is determining which of these 2 types gets returned is kind of a problem just from an understanding, because there's nothing in the typing information that links those 2 pieces of information. And it's also not super great that your return type is determined by the logic in the function. OK, so the last one, which is a little more detached from this, is that I think that you should still be providing magical interfaces, things that kind of just work for people, but you should definitely be trying to provide explicit versions of them. So as an example of this, I'm going to take another thing from DateUtil. DateUtil has this function called parse in the parser, and basically it's sort of famous for you give it anything that looks anything like a date or a datetime, and it'll create a datetime object from it, which is super great if you have some random motley collection of things that are datetime strings. But what if it's actually a bug that the string you got is in a different format, right? You're actually implementing something that says, I only get ISO 8601 datetimes, and I want to throw an error if it's something else, because that something else could be not a meaningful datetime, but because the DateUtil parser is so liberal, it says, oh, well, it says March in there, so that must mean March 3rd, 1941. Instead, I've also implemented in the parser something called ISO parse, where ISO parse takes an ISO 8601 datetime and only an ISO 8601 datetime. Anything else, it throws an error. So here I'm providing a magical interface, which is like, if you don't know what you want, just pass me a string, and I'll figure it out. And I also have this explicit version, which is more strict. And as a side effect, it's actually a little bit faster. Actually, it's a lot faster because it knows exactly what to parse, and it can fail out quite early if it doesn't get that. OK, so we have the general principles. And now I'm going to jump right into an example. So this is an example class called coordinate. It represents some location in latitude and longitude. It's basically your standard thing where someone probably implemented it once, and now 95% of the implementations are people teaching you about object-oriented programming. Not going to disappoint with that. So the idea is that it's just something, and it has 2 floats in it, and it can return this kind of nice string that represents north and east and south and west. So far, so good. But what if we say, hey, these strings are actually kind of nice, and maybe I'm going to be printing them somewhere, and maybe someone's going to want to enter that kind of string. Maybe I can make it so that I can construct these with that other kind of string. So I can try and be nice and magical about it, and I can say, yes, our constructor is going to have 2 different ways to create it. You can either pass it a string, or you can pass it 2 floats. And this is a little bit messy, but it works just like you would want. But when we go back to our thinking about the function signatures, what I wanted was something that looks like this, right? Where I have one version of it that takes a string and returns a coordinate, and another version that takes two floats and returns a coordinate. But what I got was this kind of monstrosity, which takes a union of a float and a string, and then it has an optional float afterwards, and that returns a coordinate. What I wanted was function overloading, but what I got was some other kind of thing. And if you're just being super naive or trying to generate examples from the type checks, you'll see, like, oh, it seems like, according to the type checking, that I should be able to pass a string to the first one, and then for whatever reason, the second one can't take strings. But this should be fine, but it doesn't. It's not fine, because that's not how it's supposed to work. You might also think naively, like, well, since the second argument is optional, then there must be some reasonable default, so maybe it's 0 or something, but it doesn't really matter. I can just use the first one. But here again, it's just because we haven't tied together the fact that it's either two floats or one string and not any weird combination of those. So a solution to this is to use an alternate constructor. So instead of trying to pack two things into one function, I have two separate functions. I have the regular constructor, which just takes two floats. And then I have this alternate constructor, which is a class method. And it will construct an object of the type of the class based on this string parsing logic. And if you look at it, I get coordinate with two floats. I get the coordinate object back. If I get coordinate.fromString and a string, I get a coordinate back. But none of these mix and match things will work. And if you look at the API, it's a little bit different, right, in that now I have this from string, but it's pretty close to the API that I wanted. It's got all the right type checking, and you know what you're getting when you pass things to your constructors. So another nice thing about alternate constructors is that it uses the normal inheritance tree. So I don't know why I've chosen all my examples to be locating things in space, but I guess I did. This example is going to be about points in Cartesian space. So it's got x and y. It's two-dimensional. And you don't have to know this, but there are two or more ways to represent a point in Cartesian space. You can represent it in polar coordinates or Cartesian coordinates. It's not important to know the details of that. What's more important to know is that there's a transform that goes from one to the other. And you may have your coordinates as floats in one or the other. So here, what I'm going to do is I'm going to support polar coordinates by having this alternate constructor called fromPolar. And as you can see, and then I also am going to have this static method, which instead of having it be a class method, for fromPolar, it needs to be a class method because I need to know that I'm constructing a point class. For polar to Cartesian, I have no reference to the class that it's defined on, so it's really just namespaced under there. But I still want to keep it together for reasons that will become clear later. So here I have our polar to Cartesian that converts floats to other floats, and then fromPolar, which uses that function to construct my point class from Cartesian coordinates. And you don't have to do the math. The computer did it for you. This is two representations of the same thing, and it's using the fromPolar coordinates. So now I can use inheritance to sort of, I can leverage inheritance to get a lot of that stuff for free in a subclass. So if you imagine I have a point and I want to give it a name, so 0 is going to be the origin, or some 1, 1 is going to be Bob's house or something. If I just subclass point and I add this name parameter, then it works just fine. But now if I use fromPolar, it also works. I get the fromPolar behavior for free, except because the superclass doesn't know anything about this name parameter, because the superclass doesn't know anything about this name parameter, it will, it's just going to be ignoring the name, or it'll give me an error if I try and specify the name. There's no way to make a named point from Cartesian. But I can fix this by just overriding the fromPolar method. So I call the superclass alternate constructor on fromPolar. And interestingly, I don't think I knew that you could do that with class methods until I made this slide, but apparently you can. You just call super fromPolar. It'll create an instance of the base class with the name not initialized, and then I've just modified the signature to take name, and it'll assign it before it returns the value. So now I have this thing that's named point.fromPolar. I don't have to re-implement polar to Cartesian or anything. But you actually can re-implement pull it to Cartesian, even though it's a static method instead of a class method, and get some benefit out of it. So here, I'm using, instead of a two-dimensional point, I'm looking at a three-dimensional point. And if you notice, I haven't re-implemented from polar, because from polar is already doing the right thing. It'll just take as many arguments as you want, and it just passes them to the method, the static method, polar to Cartesian, that's namespaced under the current class that it's on, right? So that CLS, I'll go back. So CLS here refers to point in the first one, so that'll be point.polar to Cartesian. And in point 3D, it refers to point 3D. So in my from polar implementation, it's now referring to polar to Cartesian. And I get, basically for free, I can either pass it 3 coordinates or 3 coordinates in polar Cartesian coordinate system. So that's some things you get from alternate constructors. And essentially, so far, everything I've been talking about is in classes. But a lot of these same API problems, they come up in functions as well. But there's not really a such thing as alternate constructors for functions, right? But maybe there should be. So we can look at, for example, this kind of thing. This is a function that it's a contrived example, but it's a pattern that you actually see quite a bit, where you have something that it's intended to take some text, right? And you have 2 options. You can either read it from a file or something, or you can open a file. You can take a path and then open that path and read the path. So the problem here is that the more general is basically this path or buffer, right? Because it's a little bit weird for that thing to be either a path or a buffer, and then you have this if-else, and the function body is very different, so the function signature is not great. But the main reason you would do something like this is because this is actually probably the API that most people want, right? Because most people, like the more general version of this that will suit everybody is the buffer version, because you can always take a path and open it and pass the file buffer to it. But 95, 99% of people are going to be like, why are you making me call this with open and pass it in? All I want you to do is take a string that points to a CSV and then tell me what's inside of it. So you have this problem where you have two versions of the same function, and one of them is widely used, but the other one is more general, and you need this explicit escape hatch. You can also see function problems like the ones we looked at before. So this is, again, from DateUtils API. It has this parse function, and it has some ability to ignore fuzzy tokens. So it's like all this stuff that's not a date in the string. It can just ignore those if you tell it that it's supposed to parse it as a fuzzy date. But sometimes you actually want those tokens for some reason. So you can pass fuzzy with tokens. And now we have this weird API that I was warning against before, where you have the return type that depends on logic in the function. So let's look at this. Let's look more closely at this print text thing, because the solution that I have for it is something I call variance, or function variance, which is if you think about the constructor of a class. A class constructor is basically just a function for the class. It's the constructor function. And if you can have alternate versions of a constructor function, can't you have alternate versions of other kinds of functions? So let's look at how that looks for print text. So print text would be, maybe the main thing is you pass it any kind of text and it'll print it. And then we have this alternate version that takes it from a stream, and then it just prints whatever in the stream. And then maybe we can have another one that takes it from a path. So this is a library that I wrote. You don't have to use my library to implement this. It's really just syntactic sugar. As a little bit of a backstory for this, this talk actually came from an argument that I had with a coworker, where I was saying something like, maybe we should have this thing where we have a function hanging off a function. He was like, no, that is super weird. Like, why would anyone do that? And I was like, well, what's so weird about it? He's like, it's not Pythonic at all. And I said, well, what does it mean for something to be Pythonic? He's like, well, no one does it. And so my goal here is to convince you all to do it, so that now retroactively, I will have been right in this argument. So please go forth and spread the word. And you can use my library to make it super easy. And the way the library works is you have some function, you decorate it as primary, and this is similar to decorating something as a property. Once you decorate it as a primary, it adds this variant decorator to the end of the function, and then you can decorate other versions of the function with this. So here it's printText.fromStream. And so now I have my original definition of printText, then I have printText, and this second one is defining from stream. That one takes a buffer. And what it's doing is actually, it's reading the buffer and then it's passing it to the primary. So the variants can call the primaries. And now I have this other variant that's a path, and I say, okay, this can take a pathlib path or a string, and whatever it does, it opens it, passes it to the from stream. So now the variants can call other variants, or they can call the primary. And the example we used, it works just fine, right? You pass it hello world, it works. You pass it a stream that says hello world, that works, and you can open a path and it'll read the path and say what's inside of it. So this is an example of explicit dispatch. Explicit dispatch is useful because, I mean, so far we could have just dispatched on the type or something, but in this case we have, but you could also say maybe you have two things that are strings, like maybe you have a path that's a string and you have a URL that's also a string. So when you're in this kind of stringly typed situation, you may want to explicitly dispatch to either paths, URLs, or just, you know, the main function, which also takes a string. And Variance will let you do that. But maybe you'll say, okay, other than explicit dispatch, there is this other pattern called where you can implicitly dispatch with single dispatch. And this is actually fairly common. It's in the standard library. And it works a similar way. You register something as a single dispatch main thing, and then you can register on it different objects. And so I can actually accomplish this previous thing by saying anything that's a path, you just have to make it a pathlib.path. And then when I want something to be a URL, you should actually just strongly type your URLs instead of having them just be strings. So then you just have this thin wrapper class that's just a string called URL. And it actually works just fine. So actually, never mind. I guess I lose the argument. But maybe we could just do both. Because Variance is compatible with single dispatch. So you can say this primary version, which is the magical version, which just takes whatever, that is the primary, and it's also the single dispatch. And then for each variant, you just register whatever its object is. So here, I've registered printText from path as taking a path. So now if I call printText, I get hello world. With hello world, it just works. And if I call it with a path object, it also just works. Or if I call it with a from path and with a string, that will work as well. But if I want to have the explicit version that's extra strict, I can say printText.fromPath, and if I pass that something that's not a path, it won't just print it. It will actually fail. So you have your magical interface and your explicit fallback. Another thing that Variance can do that is not easy to do with single dispatch is to solve this problem with the parser, where the parser had this issue where its return type depends on the values that you pass to it, right? If I solve this with Variance, I can say, all right, I have my fuzzy parse function. That's the primary. And then I'll just have a variant with tokens. So now instead of dispatching on type of the inputs, I'm explicitly dispatching to another version that has a different return type. You can also have variation in caching behavior. This is a pattern that I actually use in DateUtil in the time zone module. It doesn't use the Variance library because these are actually quite easy to implement even without Variance. But the idea would be, all right, I have this main function, which is called getConfig, and I'm using LRU cache to make this a cached function. So if you call it more than one time, it'll try and hit the cache. And then I also have a variant of it called no cache if I want to explicitly have a cache miss. So you can see if I call getConfig, first it'll retrieve the configuration. If I call it again, it hits the cache. And then on the third time, if I'm like, don't give me the version from the cache, I can just call getConfig.noCache. And you can see this is an example where, in fact, the primary is calling the variant instead of the other way around. OK, you can also get variation in async behavior. So async is something that a lot of people are interested in these days. And one of the problems with async is that you can't really call they tend to create like parallel hierarchies because everything that's an async function has to call other async functions. So you end up having like async versions of every single thing, and you're repeating a lot of the same code. This doesn't help with the repeating of the code, but it could help with the namespacing, where say you have this function that's an async def called myfunc, and then you might have a variant of it that is just a regular function that is just a generator. So I have myfunc, and you pass it gives me async generator myfunc.sync. It's a regular function. OK, so this brings me to a sort of conclusion point, which is one other general principle that I didn't mention, but I kind of hoped would be obvious from, or I guess would hoped would emerge throughout the talk, which is that syntactic marking of relatedness is actually quite a useful function. So one good counterargument to why should you use variance is you can just use underscores. So you can just like take that dot and turn it into an underscore, and it's like exactly the same. And it's true, like this is a convention, right? But it's a lot harder to tell someone like, to tell something like Sphinx that I'm using this convention in this particular place. This is where you need to break on the underscore. Whereas with variance, I'm syntactically marking it. And so it was quite easy for me to write this Sphinx autodoc variance Sphinx extension that will take your library and it'll figure out what all the variants are and group them all together under this one big heading. So that, again, you could collapse all these. It also gives you clean top-level APIs. So if you come back to your people who are just tab completing in IPython, if I have some function that's like prime factors from decimal, from float, if it's all underscores, you can see that there's all these functions for them to choose from. If I put all the different variants under one top-level function, you can see I do PRI, and I get the 3 top-level functions. And then once I complete to the one that I want, I hit tab again, and then I see all the variants. OK, so to conclude the talk, I would like to suggest that you don't take these things that I've said as a given. When I first gave a lightning talk about this, I asked the audience, like, please tell me why I'm wrong. And that still stands. So you can come up to me afterwards and say, no, this is horrible. I agree with your coworker. Because obviously, I want to win the ultimate prize, the universal recognition that I'm right and my colleague is wrong. But one thing I've learned working at Bloomberg and at Google is humility, because I've had a lot of very smart colleagues in the past. And so I'm not trying to stand up here just because I've got the microphone and say, like, I am 100% right. Though, Matt, if you're watching this video, I'm 100% right. And what would a talk about variance be without a variant of the conclusion slide? So I would say I would like to just put in a plug for variance. My library is on PyPI. You can go on GitHub. I am happy to take contributors. It's a very small library, and it has a couple of open issues. It's pretty much ready to be used. I know that some people are using it already. And yeah, finally, you can find me on GitHub or Twitter, and I'll be around the conference. So I think we maybe have a little time for questions.
All right. Thank you so much, Paul.